Okay, last but not least, the really important thing of stoichiometry is doing a full stoichiometry problem. And so what I mean by that is you have a chemical reaction occurring, you're starting with X amount of material, and basically you want to figure out how much product is formed. So let's look at this example because this is going to bring all the skills we just practiced together. So we have 1.6 grams of silver nitrate reacting with zinc. I want to know how many grams of silver metal will form. So what we're going to start this problem with is we're going to start with a chemical reaction and we're going to balance it. So I have 1.6 grams of silver nitrate. The first thing I want to do is I want to figure out what silver nitrate is. So I have to crisscross to figure out the chemical formula. Silver is Ag, and silver is one of the few transition metals where it only has one charge, so it's +1. Nitrate is a polyatomic, so that's page 2 of your reference table. The formula is NO3-. So what we're going to do is we're going to crisscross. So we get AgNO3. So what we're doing is we're taking silver nitrate, AgNO3, and we are reacting it with zinc. Zinc is just a metal, so it's just going to be Zn. Then what it's saying is it's saying that we want to figure out how many grams of silver metal formed. So I know at the very least I'm forming silver. So what this is looking like is a single replacement reaction where zinc is going to come in and kick silver out of this bond. And so zinc is going to bond with nitrate. So what that means is we need to now crisscross zinc and nitrate. Zinc is another transition metal where it only has one charge. It's +2. And nitrate is still NO3-. So when you crisscross that, you get ZnNO3 2. So from here, what we're going to do is we're going to balance this chemical reaction. So I have one silver, silver's good. I have one nitrate molecule, but I have two nitrate molecules right here. So what I'm going to do is I'm actually going to throw a 2 right in front of AgNO3. What that does is it unbalances my silver. So now because I have a 2 right here, I balanced out nitrate, but I unbalanced silver, so I have to throw a 2 right here. Now I want to check zinc. There's one zinc. We're good to keep going. So first things first with stoichiometry is you need that balanced chemical reaction. So now what I'm going to do is I'm going to write out my givens and my finds to figure out what I actually have to solve for. So we are given 1.6 grams of silver nitrate. And we're looking for grams of silver metal. So now what I have to do is I have to map out the necessary steps that I need to take in order to get from grams of AgNO3 to grams of Ag. So again, we're starting with grams of AgNO3. And I'm trying to get all the way over here to grams of Ag. So what you should be thinking at this point is I have grams of one substance, I'm trying to get to grams of another substance. So the only way to convert from one species to a different species is by using moles. So what that means is your very first step needs to be to convert from grams of AgNO3 to moles of AgNO3. Now, what we learned in the second video is the way that we convert from grams to moles, and that's by using the molecular weight. And in this case, it's going to be of AgNO3. So now we're in moles. And again, the reason we're in moles is because the only way you can convert from one species to a different species is through moles. So we're in moles of AgNO3. But we're trying to get to silver, so my very next step is to convert to moles of silver. And the way you convert between moles of one substance to moles of a different substance is by using a balanced chemical reaction, because in a balanced chemical reaction, you'll have something called a mole ratio. Now from moles of silver, we need to convert to grams of silver because that's honestly a more practical unit to work with. So we're going to convert from grams to moles. And in the very second video, again, we learned to convert from moles to grams. You're going to use molecular weight, except this time it's going to be the molecular weight of silver. So this is the process that we're going to take. So the very next step that you probably want to do is you probably want to figure out what these molecular weight values are, so then we can just start calculating. So I'm going to figure out what the molecular weight number 1 is, and that's of silver nitrate. So I'm going to call that MW1 AgNO3. So what I'm going to do is I'm going to list off each atom, AgNO, and how many there are. I'm going to multiply that quantity by each atomic mass. So silver's atomic mass is about 108. Nitrogen is about 14. Oxygen is about 16. Multiply all these values out, add them together. And you should get about 170 grams per mole. Now what I'm going to do is I'm going to figure out what my next molecular weight is. So molecular weight number 2. But this time, my chemical formula is just silver. So technically you already figured this out with the last problem. So the molecular weight is really just going to be the atomic mass because you're just working with a lone atom. So it's 108 grams per mole. So now that we have the molecular weights, we have our givens, we know what we're looking for, we have all the information that we need. So what I'm going to do is I'm going to take this given value of 1.6 grams and I'm going to write it over 1. And again, we're converting, so now you're just going to set up another fraction. According to this little box train that we made, our first step is to go from grams to moles. So what we're going to do is we're going to cancel out grams, and we're going to get mole of AgNO3. And what we're going to do is we're going to use that first molecular weight that we calculated. So I have 170 grams per 1 mole. Now I'm going to set up another fraction, because what this first step is going to do is it's going to cancel out grams of AgNO3 with grams of AgNO3, and it's going to leave me with moles of AgNO3, which is good, but that's not the final answer I want, so I have to keep going. This time I'm going to cancel out moles of AgNO3 so I can be in moles of Ag. So what I told you before is that you need a balanced chemical reaction because that's going to give you the mole ratio. So you're going to go up to your reaction, and you're going to figure out how many moles of AgNO3 are reacting, and that's simply going to be your coefficient. So in our reaction, it's 2, so I'm going to put a 2 on the bottom where I have moles of AgNO3. Then I want to figure out how many moles of Ag are going to be produced. So again, in this reaction, it's 2. So I'm going to put a 2 on top. So what that's going to do is it's going to cancel out moles of silver nitrate, and it's going to give me moles of silver. So while we're in the species that we want, we're not in the right unit. So we have one more step. Our last step is to use our second molecular weight to convert back to grams. So what I'm going to do is I'm going to set up one last fraction. And this time moles of Ag goes on the bottom. So that means grams of Ag is on top. And again, grams of Ag is what the question's asking for. And when we set up our problem this way, moles cancels out and it leaves us with grams. So now we're going to go to our second molecular weight, which says we have 108 grams for every 1 mole. So now we just need to punch this into your calculator. So the way you're going to punch this into your calculator is 1.6 times 2 times 108 divided by parenthesis 170 times 2. And with 2 sig figs, I got 1.0 grams.